Okay, so I'm considering a very short and very small topic for the day. So the topic is one of the NRC topic. Okay, it's part of security once again, since we are doing the topic security from NCore NRC. So this is about unicast reverse path forwarding. So let me brief you what exactly is this. Okay, unicast reverse path forwarding. So let's say I have router 1, router 2 and router 3. Okay, let's say I have a destination here with IP 2.2.2.2. So what does a router see when it gets a packet towards 2.2.2? Basically what is router gonna see? It's checking its internal routing information base and it's just going to send it to the destination, right? So let's say if R2 is sending us packet towards R1, R1 only checks what is the destination IP and what is an outgoing interface. It's not gonna check who is the source here. It gets something towards 2.2.2. It will just see what is the shortest path to reach 2.2.2 and what is the exit interface. That's all. That's the routing behavior. Now the chances are anyone can spoof this packet. Now let's say someone called as PC over here, he can spoof this source. Let's say the source was 100.100.100.1. So this person can spoof and then it can go to R1. R1 will consider R1 is not gonna consider who is the sender. It's only gonna send whom to send it, or who is the destination. So this can cause breach here. It's kind of security breach, right? So we have to fix this kind of unicast path forwarding, okay, in the case of routing. So what we do is we enable a feature called as uRPF. Where do I enable? I enable on this interface. Okay, now what happens is, let's say over on my routing table the entry gets created for 2.2.2.2 via whatever interface is this, like FA0/0. So this is my routing base information, right? So not exactly here. Let me say over here. That makes more sense. So let's say in the routing information base, I have an entry for 2.2.2 with respective to this interface. Agree? Now what happens is, if you try to spoof this with respective to any other source interface, or if you're trying to send it over on a different interface, now this will be enabled. Okay, and this is gonna block those communications. So there are two ways this works. The first one is called as strict mode, and the second one is called as loose mode. So in the case of strict mode, it's gonna see two terms now, and then it's gonna allow it. The two terms are who is the source. Okay, it's gonna see if the packet is coming towards this, so that source is the right source, or is it coming, or is it been spoofed by someone else. Okay, so it's gonna see that if it's a genuine person or not. So that's one condition. The second condition is, if you see here, it's meant to come on this interface, not on any other interface, right? So that's the second check. What is the interface it's getting over to this router? So these are the two matching criteria. If this matches up, then the packet will be sent to the destination. If not, the router is gonna drop it, saying that the packet is spoofed. It's not the original packet. It's been sent to it's sent by different source, or it's sent on a different interface, not on the interface where we are expecting. Now, what is loose mode? Loose mode is only gonna see the source. It's not gonna see the interface. It's only gonna see the source, if the source is the rightful source, or if it's been spoofed. So these are the two things that we see in uRPF. Okay, so some of the key points here. What is uRPF stands for? It stands for Unicast Reverse Path Forwarding. Router normally checks the destination address of a packet before it routes. It's not gonna see who is the sender or who is the source. You give a packet to the router will check its routing base. It will see what is the best shortest path to reach the destination. That's the default behavior. Using this feature, I can make router to check the source address as well. So that's what I said. There are two ways. One is strict way and the other one is loose way. Okay. So as soon as I enable this, router is now forced to see the source address as well. Using uRPF in order to prevent traffic from spoofed IP address. That's the main purpose of using this feature. This is done by verifying whether the router can reach the source IP. Okay, so basically, what is how do we verify is, first we are gonna see the source IP. We will see if the reachability is there or not. Okay, that means, let's say this is the lab. Okay, and I want to reach 2.2.2.2. Now what I need to do is, I will enable my uRPF on this router. Okay, on this router, the uRPF feature is enabled on this router. How am I testing if my uRPF is working or not? So basically, I will try to ping to this, and then I'll see if I get a successful ping or I'm gonna get drop. Similar way, I can also spoof that. Okay, I'm gonna spoof that by creating another 2.2.2.2, so that my router, let's see what the router behaves now. So what is router gonna do is, router is gonna drop it. It's gonna drop it, and we can see the interface statistic where it says it's been dropped because of the verification check. So that's how we are gonna do the testing of uRPF, if I have configured a right uRPF or it's not non-working uRPF. Okay, let's say if the source address is valid, then only it's gonna forward, otherwise it's gonna drop it. If the source IP is not valid, the packet will be dropped. uRPF is a security feature that prevents spoofing attack. In the case of routing, that's something which we have to bring in the security, otherwise there is no security mechanism for such router packets. So basically, what does router do when it receives a packet which is meant for 2.2.2? It's basically gonna check what is the destination IP address, and it's gonna do the shortest algorithm in the case of IGP, and it's gonna push it. That's the work of router. It will never see who is sending that information or who is sending the packet, and there could be someone who can spoof that. Okay, who can pretend to be that, but in real that's a different network or a different person who is trying to take the access of your 2.2.2. network. If the packet has to be routed, check the routing table for the destination, select the correct interface, outgoing interface, and it will forward, right? So your router really doesn't care that who is source IP. It's not important while making the forwarding decision. So because the router does not check the source IP, it's possible for attackers to spoof the address, and that's where I'm gonna make use of uRPF feature. It's a feature, security feature on a routers. So what does this do is it's gonna see the matching entry in the routing table for the source IP address. That's the important term, or that's the main definition of uRPF. It's gonna see the matching entry in the routing table for source IP address. Now there are two ways. You can keep it strict mode or you can keep it loose mode. Strict mode is something where it's gonna check two things. One is source IP as well as the source interface, if it's coming on the same interface or not. The two things have to match. Only then the packets will be forwarded to the destination. Otherwise it's gonna drop. Okay. So in the case of strict, there are two matching criteria. The first criteria say what is the source IP? Is it the right IP? Is it as per the routing table? If that's good, it will go to the second one. Second one says, is it the same interface to reach this source? Because there is chances that, let's say this is one router, you have second router, this is the destination, right? Let's say you're getting the source IP from 2.2.2, or let's say it's coming from 1.1.1. Okay, but what if you also have something 1.1.1 configured here and you're trying to like spoof it, but in real the device is someone else? So that's easy for someone to break the first point, right? So the second point says it should also come to the same interface that's been in the routing information. So the RIB of this router should know if that's on the right interface or it's coming to a different interface. So based on the two statement, your forwarding will happen to the destination. Okay, that's in the case of strict. So if the packet is checked and if both the parameters are executed, then it's permitted. Otherwise it's gonna be dropped. So this is for the lab, which I'll do in some time. So let me also tell you what is loose mode. Loose mode is when the router will only check a single parameter. Okay, and the parameter is that what is the source? What is the source? It's not gonna see the interface. The reason is, if you know what is asymmetric, so that can bring this down, right? So asymmetric is something where you send the information on one interface and you receive it on a different interface. So in this kind of scenarios, you cannot keep the strict mode, because that will always put this routing into disabled mode or drop mode. So in such scenarios, you can keep loose mode. So even asymmetric routing will can be supported in the case of loose mode, and also you can keep the first parameter that the source has to be checked upon. So that's the parameter for in the case of loose mode. It's not gonna see the interface, because you never know, it might come on asymmetric routing, like you send the packet on one interface but you receive it on a different interface. That's mainly seen when you have like more than one ISP. Okay, let's say this is your enterprise and you have one connection with Airtel and you have the another internet service provider with Vodafone. So you are sending the packet on this, but let's say you're receiving this, and if you have the strict mode of uRPF, then basically it's gonna discard it because it's coming on a different interface, right? So you don't want to keep that on a core layer. So here you can make use of the loose mode. So it's only gonna check the source, but it's not gonna bother about the interface. That can be a different interface. Okay, and yes, there's one limitation. If it's on null, then it's gonna get dropped, because that can be spoofed once again. So if the only exception is if you have any source with null interface as the outgoing interface, then the packet will be dropped. So this is only one terms that you have to consider in case of loose. This is especially in the case of the unicast routing, where there's no security and you have to restrict the packet flow. So I'll demonstrate this on the lab. Might be it will more helpful to understand. So let me consider this block. Okay, so I can show you a few things here, and let me also put this label here. Okay, uRPF. So let me just reload the other routers so that I can show the configuration from scratch. Okay, since we had used this particular portion for route reflector, so luckily I have the configuration of interfaces. I don't have to do anything on the interfaces. I don't need BGP or something, because I am going to put a static route. Okay, so I'll also show you what extra thing I did here. I just created one loopback, that's all. Okay, so I'll say this to be 2.2.2 2.2.2 slash 32 network, a loopback address. We can consider loopback 1. Okay, and the same thing for testing purpose, I have to create the same loopback on this side, and then we see how is this feature gonna impact or gonna create the security concern on a router in terms of routing. Is it really gonna see the source, or it's just still not gonna check the source? Okay, so what I'm gonna do is, let's say this is the real person. Okay, and but this is a spoofing person, the person who is trying to pretend to be 2.2 and sending to this person. So is this person gonna forward it, or it's gonna drop it? That's something which we have to do. So I'll just try to get it here. So a lot of things we did that we don't find a place now. And I'll put this as spoofed. Okay, a spoofed network versus real network. One second, guys. Okay, sorry about it. Okay, so a real network versus a spoofed network, and where am I going to create the uRPF is over on Sao Paulo 26. Okay, so I can mention it here so that we have all the things documented or structured properly. I have the three routers from my previous configuration. I just need the interface IP. I don't need any BGP or something. Okay, so on all the three I have network the interface configuration. Okay, the two interface, which is a center router. So I can brief exclude unassigned. Okay, so what I'll do is on Sao Paulo 28 and Sao Paulo 27, I'll create two loop backs with the similar IP address. So let's say loop back 1 IP address is 2.2.2, 255, no shutdown. So this is my first router. So from 26, if I do show IP route, I don't have anything for 2.2.2 because I don't run any protocol. Okay, so I can show you. So I don't have any protocol, even though we used it for the BGP protocol. I have not saved that configuration because I told you I don't store or save the routing information. I only store the interface output or interface configuration, so that in the next class I can show some other protocol. So you can also do the same thing in case of saving everything, and later on if you want to practice something, then that can lead to some issues with respective to your previous configuration. So keep only interface configuration. Rest you do it as per you go with your studies. If you're going with uRPF, go with that configuration. If you're going with any other protocol, you can prefer it to configure on the spot. It will be like a refreshing your memories also, instead of depending upon the pre-existing configuration. Okay, so there is no protocol right now, and you can also see that there is no 2.2.2 network, right? So what can I do is I can just write an static route saying IP route 2.2.2, prefix is 255.255.255, and on which interface is this going out? So to reach 2.2.2, it's going out of on this interface, right? It's going out from 0/1. So what does it say? It says forwarding router's address. So that's not this, instead it should be this. Okay, so it says that it's going out of this interface, the next hop gateway. We call it as next hop gateway. Either I can give the interface IP. Okay, I can give interface IP, which is 26.1, or I can give its own interface or its own interface number, that's Ethernet number. So there are two ways I can configure the static route. If you remember, we talked about two ways of configuring static route. So let's say if I have to reach to this network from this, I can make use of next hop gateway, which will take me to this, or I need to tell my packets that take this exit route or this interface, and this will be connected to this. So basically your packet is coming to here, and then it's gonna be taking to the loopback. So there are two ways you can configure. If you're going with your IP address, remember you have to give the next forwarding router's IP address. If you're going with your interface number, then you have to give which is the outgoing interface, because if you give this, that would make different meaning. It's like you're preferring this interface. So in that case, you have to make use of its own interface. Okay, so two things here. So let's go with interface one. So let me show you how do I configure interface. I'm going to configured 0/1, that is this. Okay, because if I say this, then this is considered. If I tell this, then this is considered. So this is the way it reached to 2.2.2. Okay, that's one method. The second method would be I can give the forwarding IP, that this is the forwarding IP. So let's say this is the way. Okay, and let's see show IP route. Do I have anything for 2.2.2? So I can see this has been introduced. It's a static route. Can I ping that? It's reachable. Now let's try it from 28. Okay. Okay, I'll place you guys on mute. Okay. I hope there was no background issue. Okay. Okay, so where was I? I was on the test. So I showed you that I can ping from 26 to 28. And what about from the reverse path? Okay, that's something like if I try to ping this interface, okay, giving a source of the loopback 1, this one, loopback 1, and you can see it's reachable. Now this can lead to a issue. Now the reason is, if you see now what I'm trying to do is I'm considering this as a loopback. Okay, this as a source to ping this. Agree? Now what if someone spoofed on the other side do the same thing? He can also be reaching to the router. Now that's where I need to bring this security feature. I need to configure the uRPF so that router don't entertain this traffic, because there are two things in the strict mode. The first thing, source interface. Source, it's coming from 2.2.2 on both the side, but that's not gonna permit until the second criteria matches. The second criteria is interface, and if you see here interface is 0/1, whereas here interface is 0/0, and that's gonna not entertain the second thing. Okay, so we will do that. So how should I do that? On the second side, that's on the router 26, and on the 27, let's configure the loopback. If I have not done that, I'm going to configure that, which is required for my testing purpose. Okay, to show this on the lab, I have to do it something, right, so that it pretend to be 2.2.2 as well. So I take IP address 2.2.2, 255.255.255.255, and no shutdown. Okay, so this is the configuration which I need at this moment. Now let's configure the uRPF. So how do you configure uRPF? It's just single line of command. So let's say I go to 26, router 26, and I enable this feature on both the interface. Okay, as soon as I enable these two features, I know that 2.2.2.2 is actually binded with this direction, right? So anything apart from this direction comes pretending it's 2.2.2, the router is gonna fail, or it's gonna drop that packet. Okay, so on 26, I'm gonna consider interface 0/1. I'm gonna say IP verify. Okay, it's a unicast packet, source, pretending as a source, reachable via RX. So I told you there are two things. One is source, which is first parameter. Second thing, check the RX. RX is nothing but on which interface you're receiving that 2.2.2. So you're receiving on this, that's good thing. But if you receive 2.2.2 on any other interface, then that's going to be dropped. So over here, let's say it's RX. If I do a question mark, so it says any is okay, but we don't want that. It's a strict mode. So I'll prefer considering RX, on which interface the packet was received. So I'll do RX. Okay, so the moment I do RX, I also have to do this particular command on the next interface also. Let's say Ethernet 0/0, and I'll just copy this and paste it. Okay, I can verify if my command has been successfully executed or no. So the command is show IP interface E0/1, and if I show IP interface, if I do include verify, so you see that we have enabled some additional features now. Show IP int brief. If I just go to this, okay, so you can see we have enabled something, and on this interface, this is the real interface, everything is 0. There is nothing suspicious detected on this. Okay, the same thing if I also make sure that on the second interface, that is the spoofing interface, all is good. So it's all good as of now. Now it's time to do a testing. We will do the testing to see what happens to this interface. From 28, I'll do the same thing. Okay, it's pinging this router 28, Sao Paulo router 28, sorry, router 26. Okay, that's router 26. It's pinging router 26 pretending to be 2.2.2. Okay, that's the purpose of this command, source loopback. That's nothing but 2.2.2. So if I ping that, it's reachable. That's the good thing. That's a real traffic, right? If I do this, that's activated. If I go and try with the drops, there is no drop. So that's a good traffic. Now same command, if I do from the second router, which could be a man in middle, or which could be introduced ROG router or something. Okay, so we will see what happens. So it's not pingable, but let's see from the router point of view. If I go to interface 0/0, so that's 0.0, right? Okay. I have done a mistake on interface IP, because on this side interface is 27, so I should consider that. So the reason why we could not detect any drop is because of the wrong IP. So I'll fix this IP. Okay, and I'm pretending it to be 2.2.2, and if I ping, so there is nothing happening. Let's verify from here. Okay, so do you see the unique the uRPF has been enabled, and it started detecting the drop packets. I can also make use of debug commands here. Okay, and we will do a ping now. Okay, so basically it's getting dropped, so there's no packet being detected. Okay, if I do it from this side, so we see the packet has been successful on one side. So on the second side, if you see, even though we are pretending to be the source of coming from 2.2.2, but the router is not trying to forward it to anyone. It will immediately block as soon as it get a suspicious packet. Okay, so this is in case of routing. In the case of enabling the routing features, if you wanna enable some features, but this is not very much used in the case of enterprise. Okay, the only reason is because we have other ways to do the security, or we can enable it from other ways, like we can access list, or we can bring a firewall which can block them, right? This can be more or less, we can see in the service provider, if they are directly connecting to the enterprises, or if an enterprise core is connecting to ISP, then we can make use of this. Otherwise, in the LAN segment, we don't use of this feature, because we have firewalls, or we have the access list, where we can actually deny the packets, or we can only allow the packet which we need, right? But this is one of the features in the routing. Okay, in the routing we can enable this. Okay, now same thing I will show you in the case of loose mode. Okay, so what I do is I'll go back to that command and I'll take out the previous configuration, that is Okay, so am I on right one? Okay, so it's here, right? If I do show run interface e0/1, I'll take out this, which is a strict example. Okay, and I'll just enable the loose mode. And enabling loose mode is again a single command. So basically, if you remember, while configuring this, you had two options. One was RX and one was ENE, right? So now we are gonna put that ENE. So let's say IP verify unicast source reachable. If I do question mark, the first line, source is reachable via any interface. So that's what I'm going to enable now. So I'll do the same thing on the second interface. I'll take this out and I'll bring up this line. Okay, and what is the counters now? Okay, the counters are showing as to be 0. So let's give it a try. If I ping from this side, the real source, it's reachable and we got a lot of packets. Okay, do we have any drops? Okay, there is no drop because that's a real person. Now let's do it from the one who is spoofed, who is trying to be pretending to be 2.2.2. Okay, and what do we see? See, we see some packets now, because we are getting a packet from 2.2.2, and since it's saying that you can accept it from any interfaces, but that's not going to push it further. Okay, how do I prove? I can make use of the drop command. Okay, and you can see now it's trying to suppress those packet. It's getting dropped now, right? So two things happened. Actually, the strict mode, it was completely dropping. Okay, and we could not see any packets getting generated for the debug command. But in the case of loose method, packet received on this router, because the first parameter is not eligible. The second parameter is not eligible. That is, you can get the source 2.2.2 from any interfaces, right? You can get it from any interfaces. So that's why you received it, but then it's not going to forward it. The reason is you have this configured and the actual binding is happening on the second side, that is 0/1. Okay, that's in your routing information base. So it's gonna check routing information base. It's gonna say that this is the right source, but that is not the right interface. Okay, and it's gonna block it. So you see, it's gonna detect 0/1. Okay, it says for forest packet, stop process pack for forest packet, because it was arrived on this interface. Okay, so let's try to understand what exactly happened here. So you get a packet on 0/0 for this destination. Okay, it's gonna see the rib configuration. Okay, and then it started considering that to be, see, you can see it's checking the routing information base, and then it detected from the routing information base it's not a rightful packet. It's gonna stop the process. Okay, it's not gonna push it or do anything with that, and it will mark it as a suppressed. So if I initiate few more things, so you can see it's considering, it's going till rib, but rib will mark it as suppressed, or that is equivalent to getting dropped only. Okay, so these are two things. The first one, you can use it in your LAN segment where you don't have the asymmetric concept. But when you have some enterprises where you have multiple ISPs, so you can have the asymmetric happening. You're sending the packet on one ISP and receiving the reply on the second ISP. So in such scenarios, you can make use of the second method, that is the loose method. Okay, so you can get it from second interface as well. So let me once quickly see the NRC topic. So we have this topic left in the security. Okay, COPP. And yes, we will then come with some BFT and VRF. It's a easy topic. Okay, VRF and all. It's just you're segregating the routing base with respective to different customers. Okay, so we are going at good pace and we have done a lot of topics. So you have ACL and COPP also in ENCORE topic. So this is the PDF which is not been highlighted. This is the original PDF. So don't get confused. We have another PDF where I have highlighted like how we have highlighted in the NRC case. All right, guys. So that was from my end. So do you guys have any doubt? So let me see the chat window. So there is no latency with this. It's a features that we enable. So frankly speaking, even I have not seen this kind of feature anywhere so far. Okay, that someone having this. But yeah, this is a part of syllabus, so you need to know from the certification point of view. And yeah, one small thing that might be I missed with respective to this topic. What are the additional features, the additional features that you can bring over here? So you can have the logging and exception. So basically uRPF allows the usage of access list. Okay, so you can make use of the access list and you can decide what is the source, which one to be allowed, and you can also log the packet for the same if something is getting dropped. Similar way, you can also allow self pinging, because most of the time when you have the routers or routing, you will do self pinging. So that is also allowed, or that's also we can have this in case of strict mode. We can have the self pinging enabled. And default route, so there is two things now. One is default route and one is the normal static route, right? So you don't want one to get considered to be dropped, or you can see to check the source IP address against the default route. So basically these are few features which you can incorporate with uRPF. So guys, any doubt? Alright guys, so let's meet up in the next class and have a nice day and have a nice weekend too. Thank you everyone.